Welcome to YouTube channel scientific underscore math. We are solving a system of linear equation using the Gauss elimination method. In earlier lectures, we discussed Gauss elimination method, Matlab code for Gauss elimination method with pivoting, and Matlab code for Gauss elimination method with pivoting. I will provide the link in video description. You can watch all these lectures. Here we are going to learn Gauss Jordan elimination method, and we will solve related example, and in next lecture we will write a program code for a Gauss Jordan elimination method in Matlab. So let's move toward today lecture, Gauss Jordan elimination method. The Gauss Jordan elimination method is a procedure for solving a system of linear equation Ax is equal to b. In this procedure, a system of equations that is given in a general form is manipulated to be into equivalent system of equations in the diagonal form with the normalized elements along the diagonal. Okay, so what is normalization? We study definition of normalization. Okay, so first I will show you these are the system of linear equations. We apply the Gauss-Jordan elimination method, Gauss-Jordan elimination method on these system of linear equations, and we get the equivalent system of linear equations with the normalized elements along the diagonal. Okay, the pivot coefficients all are equal to 1. These are 1. These are the pivot coefficients. Okay, so what is normalization? Okay, the pivot equation, the pivot equation is normalized by dividing all terms in the pivot equation by pivot coefficient, by pivot coefficient. Okay, by pivot coefficient, this makes the pivot coefficient equal to 1. So this is the pivot row, and this one is the pivot coefficient. We divide the pivot row with pivot coefficient to pivot equation, or the pivot row divided by the pivot coefficient to normalize. Okay, so we can write the system of linear equation in matrix form. Okay, so this is the matrix form of the system of equations, and when we apply the Gauss elimination method on the in this matrix, we get the equivalent form of this matrix is this, and here the pivot coefficients or the diagonal entries all are equal to 1, and the new obtained vector b dash is the solution of the system of linear equation x1, x2, x3, and x4. Okay, so this is the we can also say that this is the identity matrix, and this means that when the diagonal form of the matrix of the coefficient a is this is the matrix, and we reduce this matrix into the identity matrix, reduced to the identity matrix, the new vector b dash is the solution. This is the new vector b dash is the solution. Okay, so let's solve example related to the Gauss Jordan elimination method. We have a system of linear equations, four system of linear equations, and we write this in this form, matrix form, and then we write the augmented matrix AB. Okay, so here we have the pivot row, this one, and this is the pivot coefficient. This is the next pivot row, and this is the pivot coefficient, and similarly, and so on. So first First we normalize this equation by pivot equation by dividing pivot coefficient. Okay, so divide the pivot row 1 with the pivot element 4 to normalizing the pivot row. So this is the pivot element or the pivot coefficient. So here we have a normalized pivot equation with pivot coefficient 1. Okay, so now we eliminate all these terms, this one, and this one. So we multiply this equation, pivot equation, we multiply pivot equation with -6 and subtract from second row or the first second row. Okay, so multiply row 1, and this is the row 1, multiply row 1 with minus this term and subtract from second row. We will subtract from this row, and here we can see that this is equal to 0. Okay, next we multiply this term with 1 and subtract from this one. Okay, so multiplying row 1 with 1 and subtract from row 3. So we multiply row 1 with 1 and then we subtract this one from 2 from 3, multiply. Okay, so we get this one and this is eliminated. No, this is equal to 0. Next we multiply this equation and subtract from this one. We multiply uh, r4 minus, we multiply this one by -12 r1, and then we get new r4, new row r4. Okay, so multiplying row 1 with -12 and subtract from the row 4, r means r4 minus 12 into r1. This will be equal to r4. So here this is eliminated. Now we again normalized, this is the pivot equation. We normalized this pivot equation by dividing by 4. Okay, so divide the pivot row 2 with the pivot element 4 to normalizing the pivot row. Okay, so here we can see that this is the normalized pivot row. This is the normalized pivot row. Okay, now we will eliminate all these terms, all these terms. Okay, so first we multiply the pivot row or the second row with minus 1 by 2 or 0.5 or 2, and we will subtract from this r1. This will be equal to new r1. Okay, so we have multiply r2 with this one and 0.5. This is equal to, and subtract from r1. Now this is eliminated. Now this is equal to 0, and next we multiply this one with r2, and next we multiply this one with r2 and subtract. Okay, r2 with this one and subtract from r3, and okay, this is equal to 0. Now r4 minus 16 times r2, this will be equal to r4. Okay, so this is we can see that multiplying r2, this is r2 with 16 and subtract from r4. So r4 minus 16 times r2, this will be equal to r4, and this will be 0. Okay, now this is eliminated. Next the pivot row is this one. We normalized first this pivot row by dividing by 2 3, and so we have pivot row with the pivot element 3 by normalizing. Okay, so this is equal to 1, and this is the normalized pivot row. Okay, now we will eliminate all these terms by multiplying with this one and by subtracting. So first we multiply r3 with minus 1 by 2 or 0.5, means r1 minus 0.5 with r3. This is equal to r1, and here we can see that this is eliminated now. Now we eliminate this one and this one. Okay, so this is 0, and now we multiply R3 R3 with minus 3.2 and subtract from R4. This will be R4. Okay, now this is also eliminated. Next, the pivot row, we have this one, and first we normalized this one by dividing by 4. Okay, the pivot row is and dividing by this one to normalizing the pivot. Okay, so this is equal to 1. This is normalized now. Normalized pivot row. Okay, so now we eliminate this term, and this term. So first we multiply R4 with 37 by 24 and R subtract from R1, which is equal to mu R1. Okay, so multiplying R4 with this one and subtract from row this one, and we can see this is normalized now. And after this one we eliminate this term. Okay, so after doing some simplification, okay, so this is the matrix, augmented matrix, and here we have this is we can write this in ax in this form. Ax is equal to b. Okay, so this is 1 0 0 and 0 0 1 0 0 0 0 1 and 0 0 0 and 1. This is the coefficient matrix, and here x1 x2 and x3 and x4, which is equal to 2 4 minus 3 and 1 by 2. So after multiplication we get this one, and this is x1, this is x2, this is x3, and this is x4. So this is the Gauss Jordan elimination method, and in next lecture we will write a Matlab program for the Gauss Jordan elimination method. Please subscribe my channel scientific underscore math. Thank you so much.